Okay, hi everybody. We are going to be discussing today the basic chemistry of life. So covering the information that was in the CK12 reading that you just did. So let's get started. Okay, so as many of you who were at PRS last year might have remembered, you guys did some work on the periodic table and maybe even made some superheroes for each of your different elements on the periodic table. So we're going to be building off of that today as we go through this sort of lesson on chemistry. So chemistry, as you may remember, is the study of matter, its properties, and their interactions. Okay, so how different types of matter interact with one another. So this is a review. Can't see my little review thing. This is a review of basically what atoms look like, and hopefully you remember this from last year. So remember that an atom is the basic unit of a chemical element. Remember, those elements are the things that you find on the periodic table. And each element is defined by the number of protons that it has in its nucleus. So this atom here has 6 protons in its nucleus, which means it is a carbon atom. If it had a different number of protons, it would be a different type of atom. It would be a different element on the periodic table. Neutrons, however, can fluctuate. And as you may have remembered from earlier this year, if we change the number of neutrons, then that means that we have a different isotope, or maybe like we say a flavor of that particular atom, like we talked about when we were doing carbon dating. And then lastly, we have our electrons that circle around the outside. And remember that electrons are negatively charged, while our protons are positively charged, and our neutrons are neutral. So hopefully this is sort of jogging your memory a little bit about some basic information about an atom. All right, so we can take atoms and we can combine them together to create molecules. We can combine together 2 of the same type of atoms so that we make something like molecular oxygen, which is a molecule of oxygen, which remains an element because it's made up of just one element from the periodic table in this molecule. And these would be similar, right? So we have P4, phosphorus, and S8, sulfur. So these are molecules that are made up of just one type of atom. And then we can also bond together different kinds of atoms to make molecules that are called compounds. And it's important to remember that these are the smallest unit of a substance. And we'll talk a little more in a minute about what is a substance. But basically, we can't break these down any farther without breaking bonds, and in which case we would change the identity of the molecule. So it's kind of like the smallest unit of a substance. Okay. So we're going to be talking for the next several slides about how we classify different types of matter. And so we're going to be using this diagram to sort of help make sure that we understand the relationships between the different types of matter and how they sort of go together. You should definitely make sure you have this diagram in your notes. You're going to want to refer to it and you should be able to explain it well at the end. All right, so we've defined what is matter. Now we're going to be taking a look at the differences between substances and mixtures. So let's start with substance. So a substance is a form of matter that has a constant chemical composition and characteristic properties. Well, what does that mean? That means that the chemical composition of the substance can't change. And if we change it, then we end up with a different type of substance, right? That substance is going to have some really characteristic properties. So right here, we see some different types of chemical substances: helium gas, which has its own properties and chemical composition; water, which has its own properties and chemical composition; and salt. So we're showing sort of the gas, liquid, solid options here. We can't separate this substance into smaller components without breaking chemical bonds, which means without doing a chemical reaction. So these, again, are the smallest sort of unit as a molecule of these different substances. And you may have seen the use of the word pure substance, which means that a sample would only contain one type of molecule. So this could be a pure substance, water, if it only contained just water molecules, which actually in the natural world is pretty rare. Usually there's some other dissolved stuff in our water, right? Like salt water, for example. But in this sample here, this is pure water, so it's a pure substance. Substances can have different properties from the elements that make them up, and this depends on whether the substance is an element or a compound, and we're going to talk about that in the next few slides. Okay, so substance is not some weird goo on the bottom of your shoe. It has an actual definition, and it basically means that it's this constant chemical composition is a very specific thing, and if we change the arrangement of the atoms in a molecule, then we get a different substance. All right. Oh, some examples here. Water, carbon dioxide, sodium chloride. Sodium chloride is the fancy name for table salt. All right, so let's move on to mixtures. So mixtures are formed when we take two or more of those substances we were just talking about and we just mix them together. So the substances don't bond with one another. They just get mixed together. And so they can be really obvious like this, right? We know that the M&Ms and the peanuts and the raisins here are not bonded together. We know that the oil and the vinegar are not bonded together. Some other examples can get a little trickier, but these ones are kind of easy ones. So substances within a mixture each maintain their original properties, right? So a peanut is still a peanut, an M&M is still an M&M. The properties of the various substances don't change. But the amount of each type of substance can vary without changing the identity of the substance. So that's different too, right? We said in a substance, we can't change anything about it or it becomes a new substance. But in this case, we can. Like if you're allergic to peanuts, we could leave peanuts out of our trail mix and it's still considered trail mix. Or if we like white chocolate kisses, right? What do you call those? Chocolate chips, white chocolate chips. We could put those in there and it would still be considered trail mix. So we can change the amount of the different substances within a mixture and it still can be the same mixture. And we can separate the different substances without breaking any bonds, right? We could pick out all the peanuts and all the raisins and all the M&Ms and we could separate them, or we could use some sort of mechanism to pour off the oil from the vinegar and we could separate these different substances. If it was salt water, which is a type of mixture, I could boil off the water and separate the salt from the water. So I have ways of separating that don't require the breaking of bonds. Okay, so review substances versus mixtures. Substances have this fixed chemical composition like H2O. If I make it H2O2, it's no longer water, it's now hydrogen peroxide. So the composition is fixed. Whereas a mixture, the composition can vary. I can add more M&Ms, I can take out the peanuts, and it still is the same mixture. We can't break down a substance to anything smaller without a chemical reaction, meaning without breaking the bonds, but we can break down the mixture and separate them into their various parts. A compound, which we're going to be talking about next, is a type of substance that has properties that are different from the elements that make it. So we'll talk a little bit more about some examples of this as we move forward. And in the case of a mixture, each component, each substance in the mixture maintains its original properties. And we have some examples here. So we have water, we have salt, we have oxygen as our substance examples. And then we have a mixture of salt and water to make salt water. Lots of different types of grains of sand mixed together to make sand. And milk has lots of different parts to it, right? So you may have heard of homogenized milk, and we'll talk about homogenized and homogeneous mixtures soon. Okay, so substances and mixtures. Both of these are different types of matter. Just like we saw here, matter, substances, mixtures. So now we're going to move on and we're going to talk about two types of substances, elements and compounds. All right, so remember, a substance means that we have a definite chemical composition, okay? So an element is one of two types of substances where there's only one type of atom present. So we have these two oxygen atoms bonded together in this example to make molecular oxygen. And this has some unique properties based on the properties of the element found on the periodic table. So oxygen on the periodic table has specific properties, and we have their own specific properties here as well. So pure gold, oxygen, anything that's bonded to itself would be an example of an element. But in a compound, we have different atoms bonded together. So two or more different types of atoms bonded together, right? So this is a water molecule. We have an oxygen plus two hydrogen atoms bonded together to make water. And the properties of this compound are different than the properties of the element that make it up. So hydrogen is flammable. Oxygen helps things burn. When we bond the two together, we make water, and water, as we know, is not only not flammable, but puts out flame. So the properties of water are different from the properties of the elements or the atoms that make it up. Okay, moving on. So we've talked about substances, definite chemical composition, two types, elements, which only have one type of atom present, and compounds, which have multiple types of atoms present. And then we have mixtures. And we talked about how these do not have bonds between the different substances. They're just mixed together. And now we're going to talk about the two different types of mixtures, homogeneous mixtures and heterogeneous mixtures. And you may remember the prefix homo means same. The prefix hetero means different. So that might help us as we go through this process. So looking at the different types of mixtures, both homogeneous and heterogeneous. So homogeneous mixtures means that mixed evenly, or sometimes we say the same throughout. So homo means same, the same throughout. That means we can't see the different parts, not even with a microscope. So it might look like a substance, but it's really a mixture. So salt water is mixed so evenly that it's mixed at the molecular level, a molecule of salt, a molecule of water, right? Air is similar. When we look at air, we don't see the different parts. And brass is an interesting mixture of two different types of metal that solidify together, but actually are not bonded to each other. Whereas a heterogeneous mixture is an unevenly mixed mixture. So the various parts can be seen sometimes even with the naked eye. So the examples we looked at before, trail mix, salad dressing, smoke, we can see the different parts in a heterogeneous mixture. All right, so a review of the classification. Matter, right? This is basically everything that we can see, right? And sometimes not see, like air. Made up of atoms. We have pure substances and mixtures. So pure substances basically have a definite chemical composition. And if they're all the same type of atom bonded to itself, it's an element. If there's different types of atoms bonded together, then it's a compound. Mixtures are different types of substances that are mixed together and they don't bond with one another. We can separate them back into mixtures if we want to. And there are two types of mixtures, homogeneous mixtures, which are the same throughout, and a solution is a type of homogeneous mixture where we dissolve one type of substance into another, usually one of which is a liquid. And then we have heterogeneous, which are unevenly mixed, and we can usually, not always, but usually see the different parts with the naked eye, or at least with the help of a microscope. Whereas this, not even a microscope is going to allow us to see this blending of these two different substances at a molecular level. Okay, almost done. Representing compounds and formulas. So what's the difference between a chemical symbol and a chemical formula? Well, these are chemical symbols. These are maybe what you might see when you look at the periodic table. It could be one letter, like carbon, or it could be two letters, but the second letter will always be lowercase. Okay, so when you see an uppercase, lowercase, those two go together. And note that it is not always something that starts with the letters of the word, right? So silver is Ag, not Si, because Si is silicon. Okay, so these are the chemical symbols. Capitalization matters here. And then this is the chemical formula for glucose. So the C is carbon, and the 6 tells me that there are 6 carbon atoms in this molecule. And the H is hydrogen, and it has 12, and O is for oxygen, and there are 6. So this is the molecule for glucose, and this is the chemical formula for glucose, which has 6 carbons, 12 hydrogens, and 6 oxygens. Okay, last up. There are 4 main signs that a chemical reaction may have occurred. So these 4 things are a change in color. So when we see 2 substances mixed together and suddenly there's a change in color, then that could mean that there's a chemical reaction occurring. Gas is being released. So we mix two substances together and suddenly we start to see bubbles forming and a gas being released, right? So those bubbles are the byproduct of the chemical reaction. They're happening in a liquid and so they come out the top and float to the top. So this gas being released, oftentimes with an odor, is an example of a sign that a chemical reaction may have occurred. A change in energy. So suddenly we get heat and light, or it could be a decrease in energy. So it suddenly gets really cold instead. So think of like the hot hands, maybe, or cold ice packs, those instant ice packs. These would be chemical reactions that change the energy level. And then the formation of a solid, which is called a precipitate. So we mix two things together, we mix two substances together, and suddenly we get this solid sort of sinking to the bottom of our liquid. That is also a sign that a chemical reaction had occurred. Not all chemical reactions will produce one of these, but these are the four most common signs that a chemical reaction has occurred. Okay, so hopefully you've gotten out of this everything that you covered in your notes when you were reading CK12, and be ready to ask questions when you come to class.